Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 1, Section 8, titled Properties of Real Numbers. By the end of this video, you will have reviewed methods for identifying and using the properties of real numbers and using deductive reasoning. In that regard, you will review the process of identifying properties and justifying your steps of deductive reasoning. Additionally, you will review real-world problem identifying the property in use while adding a list of school supplies. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel and leave a like if you find this video to be helpful. Thank you. So to get started here, let's look at a definition, the definition of deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. Okay, we'll talk about this more in the video. Okay, objective 1, identifying and using properties. So looking over here, I'll read to this. It says, the properties of real numbers allow you to write equivalent expressions and simplify expressions. The summary here, that's to the left, reviews the properties of real numbers that apply to both addition and subtraction. So let's take a look at some of them. And what are they? So it says the properties of real numbers right here, the properties of real numbers. Okay. For every real number, A, B, and C. So there's basically talking about all the real numbers, and these that are going to use A, B, and C in this description here. So here we get started here. Okay, the commutative property of addition. So what is that? It says A plus B is equal to B plus A. Commutative means like taking a trip, to commute, right? So it means you can move back and forth. So A plus B is B plus A. It doesn't matter. They can commute back and forth. Commutative property. 3 plus 7, right over here. 3 plus 7 is equal to 7 plus 3. How about the commutative property of multiplication? Basically the same thing. You can say that A times B is equal to B times A. So whether you say 2 times 3 or 3 times 2, doesn't matter. In the example here, it's 3 times 7 is equal to 7 times 3. Okay? How about the associative property of addition? This is now associative. This is how they come together, right? How they talk together, so to speak, right? Are these two together plus this one, or is it these two together plus that one? So that we're going to see it. The quantity, right here, the quantity A plus B plus C is equal to A plus the quantity B plus C. So it doesn't matter how you add them together, how you group them, they still all add to the same number. 6 plus 4 over here in the examples. 6 plus 4 plus 5 is the same as 6 plus 4 plus 5. 6 plus 4 is 10, plus 5 is 15. 6 plus 9 is 15. See, same thing. It doesn't matter. How about the associative property of multiplication? Same thing. A times B, the quantity A times B times C is the same as A times B times C. So the example 6 times 4, the quantity, times 5 is equal to 6 times the quantity 4 times 5. How about the identity property of addition? A plus 0 equals A. That's the identity property of addition. It's adding 0 to anything, leaves the number unchanged. 9 plus 0 is still equal to 9. The identity property of multiplication. Now it's a 1 we're talking about. So anything multiplied by 1 remains the same. So A times 1 is equal to A. If you look over here in the example, 6 times 1 is still 6. The identity property of multiplication. The inverse property of addition. Inverse property of addition says for every A, there is an additive inverse or negative A, such that A plus negative A is equal to 0. So here, 5 plus negative 5 is equal to 0. So 5 plus or minus 5 is 0, right? How about the inverse property for multiplication? For every A, where a is not equal to 0. That's important here because we're going to be getting some division going on. So when we get to these properties of multiplication, we have to start worrying about zeros. But still, for every a where a is not equal to 0, there is a multiplicative inverse 1 over a. So what's the multiplicative inverse of 1 over a? It's a. You just flip it over, right? Flip it over. So it says here that a times 1 over a is equal to 1. And here it is again in the example. 5 times 1/5 is 1. Because when you multiply fractions, 5 is a fraction, right? So 5 times 1 over 1 times 5. 5 over 5 is 1. Okay. Okay, now to continue on with objective 1, we'll call it 1b here, identifying and using properties. It says the following summary reviews some additional properties of real numbers. And so what are they? Okay, the properties of real numbers. For every real number a, b, and c, and we're going to look at the distributive property. We've looked at that before. A times the quantity b plus c is equal to ab plus ac. Or that's the sum, okay, or the difference. A times the quantity b minus c is equal to ab, or a times b, minus a times c, ac. Examples: 5 times the quantity 4 plus 2 is equal to 5 times 4 plus 5 times 2. Okay? Or 5 times the quantity 4 minus 2 is equal to 5 times 4. Right here, 5 times 4. Where's the pencil? There it is. Minus 5 times 2. And you can see there, right? Because 5 times 4 is 20. 5 times 2 is 10. 20 minus 10 is 10. And 5 times 4 minus 2 is 2. 5 times 2 is 10. So they're both equal to 10. How about the multiplication property of 0? For every real number, n times 0 is 0. Looking at it, minus 35 or negative 35 times 0 is equal to 0. The multiplication property of negative 1. For every real number n, minus 1 or negative 1 times n is equal to negative n. Negative 1 times the quantity negative 5 is equal to 5. Negative 1 times negative 1 is a 5, is positive. So it'd be positive 5. Okay, in example 1, identifying the different properties that we're going to talk about here. Name the properties that each equation illustrates and explain what they are, okay? So if we look at the very first problem, it says 9 plus 7 is equal to 7 plus 9. So what property is that we've just discussed? So as you see, when you look at it, you see this is an addition, so it's an addition property. And you see it's 9 and 7 are switching places, right? And remember I talked about the commute when you move from one place to the other, like on a bus, you get on the bus and go from point A to point B and back and forth. That's the commutative property of addition. And it says here because the order of the addends changes. Okay. How about d times 4 times 3 is equal to d times 4 times 3. So d times 4 times 3 is equal to d times 4. So what do? We regrouped, right? It's multiplication. They're all being multiplied. So we can multiply them in any order we choose. And here they're being grouped. In the first half, they're being grouped with the d times 4. And then that is multiplied by 3. And then the other side of the equation, the equal sign, we have d times the quantity 4 times 3. So this is, how are they grouped together? It's a grouping thing. So we call that the associative property. It's the associations. How are they associated? So the associative property of what? Multiplication. We're doing multiplication. Associative property of multiplication because the grouping, right here, the grouping, the association, how they're grouped of the figures, of the factors change. And then how about t plus 0 is equal to t? Well, we're getting into an identity because how did t become t? So the identity property of addition is because the sum of the number and 0 is the number. So that's the identity property of addition. Okay. And then finally, negative q is equal to -1 times q. We talked about that. Remember, the negative is equal to really means -1. And we call that the multiplication because it's multiplying here. -1 times q, multiplication property of -1 because the opposite of a value is the same as 1 times the value. Okay. Okay, example 1, check your understanding. Name the property that each equation illustrates. And explain. So, I want you to stop your video, please, and give it a shot. And when you come back, we'll do them together. Think about it. You're no hurry here. I can wait. Okay, so go ahead and stop the video. Okay, now that you're back, let's look at what we have here. The directions again, name the property that each equation illustrates and explain. So, problem A, 1m equals m, or 1 times m equals m. Anytime we see a 1, which could be some kind of a fraction of 2 over 2 or 5 over 5, anything that equals 1 or 1 itself, right? Times the number, equaling the number, we're talking about identity. And in this case, it's the identity property of multiplication because we're multiplying. And m is multiplied by the multiplication identity of 1. That's it. For addition, it's 0, but it's added. A plus 0 equals 0. The 0 is the additive or the identity property of addition. Okay, so let's look at B. The quantity 3 minus 3 plus 4, right here, minus 3 plus 4 plus 5 is equal to minus 3 plus 4 plus 5. Okay, so what's happening? The way we're associating these numbers together, we can add like in any direction we want. It doesn't really matter. But the way we're grouping them is what we're doing. We're grouping these two and then adding the 5, or we're taking the 3 and then adding the group 4 plus 5. So this is the associative. It's how are we associating groups about how association, right? You have a group of friends. It's how you associate with your friends. Okay. Associative property of addition. The grouping of the terms changes. How about C? 3 times the quantity, 8 times 0. Right here, 3 times the quantity, 8 times 0, or 3 times 8, the quantity, 3 times 8 times 0. So in this case, we're still doing multiplication, so it's some kind of a property of multiplication. And again, we were grouping them in different groups, so we're associating them. So it's the associative property of multiplication. The grouping of the factors changed. D, 2 plus 0 equals 2. Well, in this case, we're adding, so it's a property of addition. And what is it? We see we're adding nothing and getting the same number back. That's the property of identity. So 2 plus 0 equals 2. The identity property, because 0 is added. How about this? E, n times p is equal to p times n. So what do? We flipped the places, right? The P and the N switched places. We flip-flop the places on them, right? So what is that? That's commuting. We're traveling from A to B, right? We're going to go to A to B, and then we're going to go back to B. Back and forth. It's commuting like on a bus or in your car, going back and forth to school. You're commuting, okay? The commutative property of multiplication, because this is multiplying. The order of the factors changed. How about F? It's the same thing, except this one is what? The commutative property of addition. We're not multiplying, we're adding right now. But it's still P and Q and P. They're flip-flopping, they're changing places. So it's commutative property of addition. The order of the terms change. Okay, example 2 is a real-world problem. You can use the properties to reorganize the order of numbers. in sums or products so that you can calculate more easily. So what we're going to be doing here is we're going to write down a list of products, which are these school supplies. You see them there. And then we're going to move them around to make them easier to add or subtract or multiply or whatever is necessary. So suppose you buy the school supplies shown at the right. Find the total cost of the supplies. So what am I going to do? We have, just looking at these, I have at the bottom there, I have 85 cents, and I have $2.50, and I have $5.15. Well, if I go 85 plus 250, that's 335 and 550, it's, well, maybe 100 to add. But if we organize them differently, we can move the 85 and the 215, and we can flop them around a little bit, right? And group them differently. So we could say 250 plus 85 and 515. Okay, so that's commutative property of addition, right? We moved these around. We're moving them around. Okay, and then we're going to group them through associative property of addition. Right here, we're grouping the 85 and the 515, and then we have the 250 on the outside waiting to be added after they're added here. And then what do we get? 85 cents plus 515 is $6. All of a sudden, $6 plus 250 is 850. So we added first within the parentheses, and then the number falls out. There it is. The total cost of the supplies was $8.50. So you see, we just kind of moved them around almost to do mental math, so we could kind of calculate it in our head. Oh, 85 and 515, 85. Yeah, $6, 250, 850. Kind of an easy math mental problem, mind problem. Okay, so for you, we're going to check your understanding on this. So it says, at the supermarket, you buy a package of cheese for $2.50, a loaf of bread for $2.15, a cucumber for 65 cents, and some tomatoes for $3.50. Find the total cost of the groceries. So why don't you stop it and try this yourself? You're going to write out the numbers and then switch them around into, you'll see what it turns out to, and try to make things easier to add, right? To try it and see what you come up with. I'll wait. Okay, so it says at the supermarket you buy a package of cheese for $2.50, a loaf of bread for $2.15, a cucumber for 65 cents, and some tomatoes for $3.50. So let's start by just writing them down, right? Don't matter. Let's write them down. So we're going to start off with 250 plus a loaf of bread, $2.15, plus a cucumber for 65 cents, plus some tomatoes for $3.50. Well, can we move any of these around? Did it make it easier? Well, yeah, I think we can. I want to go ahead and change colors. I'll change to green. So we could say we can leave the 250 where it is, 250, and I'm going to say plus 350 because those are going to add pretty easily, right? So, and then plus 215 and 65 cents. I got to get that. Let me fix it. I didn't get the plus sign in there. Plus plus 65 cents. Okay? So now this part over here, let's change make it red. That'll be perk it up a little bit. So 250 and 350 is $6 plus 215 and 65. Well, 65 plus 5 is 70 plus the other 10 from the 15 is 80, right? So that's $2.80. $2.80. And when you add that up, it ends up being $8.80. Okay? Okay, so for here in objective 2 of this review, using deductive reasoning. So now we're just going to talk a little bit about deductive reasoning and start getting our feet wet, so to speak, right? Deductive reasoning is a process of reasoning logically from the given facts to a conclusion. So you're given a set of facts, and then you go through a steps, procedures to keep shifting and manipulating the facts that you have until eventually you end up with the conclusion that you made, or you're going to end up with, right? So you justify each step in simplifying an expression with reasons such as the properties, definitions, and rules. You say, well, why did you make this step? Just like we did before. Well, we said the additive property or whatever. We said the identity property of addition or the associative property of multiplication. Those are the reasons. That's part of deductive reasoning. So let's look at some of these. Okay, example 3, justifying your steps. And this justifying your steps is basically what you do when you get into deductive reasoning. From step to step to step, you make a step and then you say why you did it. Right? So you're just getting a little early practice here, I guess. Simplify each expression, justify each step. So let's try it with problem A. I'm going to start off with negative 4b plus 9 plus b. So the very first thing we're going to do is we're going to add the 1 right here to the b. And how do you add that? You multiply by the multiplicative identity or the multiplication identity. We call it the identity property of multiplication. You can multiply any number by 1 and have still it's the same number. So I can add that 1. And the good part is down here below, I'll be using that 1 when I add these terms. So you'll see how that goes. So then the next step is I have the 9, the constant term between the two b terms. Well, I want to get the b terms next to each other. So I do that. I'm going to have to move the 9 and the 1b around, right? So I'm going to put the b over, I'm going to move the 9 over to here and the 1b back over to the middle. So that's basically what I'm trying to show here. So the 9 was in the middle and the 1b is at the end. Now 1b is in the middle and the 9's at the end. So now I have the negative 4b and the plus 1b next to each other. So the next thing I can do is use that was the commutative property of addition. We're adding and we're commuting. We're moving around. That's commuting. So now we're going to use the distributive property. I'm going to take the b out of both of these terms and separate it out. So I'm going to end up with the quantity negative 4 plus 1 times b plus 9 using the distributive property. And then finally, I'm going to add these two terms together, which is negative 4 plus 1 is negative 3. And then once I do that, the parentheses are gone, and it's negative 3b plus 9. And down here, a little more complicated, but the same thing. So we have 7z minus 5 times the quantity 3 plus z. And then so what will we do? The first thing I think we'll do is we'll use the distributive property to multiply the negative 5 through the quantity 3 plus z. So we get negative 5 times 3 plus negative, I'm going to put a paren right there, plus, how's that? Plus negative 5 times z, distribution property. So now I have 7z plus negative 15 plus negative 5z. Well, I want to get the z terms next to each other, the like terms. In order to do that, I'm going to move them around using the commutative property. Okay, we're going to use the commutative property. So the commutative property says I can move the 15 out here to the outside over here, and I can move the 5z, negative 5z into the middle. And I've just done that. So then using the distributive property, I have 7z plus negative 5z. I can pull the z out and say that 7 plus negative 5 times z, then plus negative 15, which eventually will just end up being negative 15 when we're done. So now I can add the 7 plus negative 5 and get 2 times z, plus negative 15. So completing it, that's addition. I use the distributive property up here to pull the z out, right? So now when we're finally done, the definition of subtraction, we can subtract the negative 15 from the positive and get negative, right? So now we have 2z equals negative 15. Okay, example 3, check your understanding. Directions. Simplify each expression and justify each step. So this is like getting us closer to this deductive reasoning where you make a step and then you say why you made the step and what allowed you to make that step that you made to allow you to get closer to your conclusion, right? Deductive reasoning. So we're going to do them here. So this is a check your understanding. So I'll go ahead and wait. You can go ahead and slip off and stop the video, and then when you get back, we'll try to work them together. Okay? Okay, so now you're back, and we're going to look at this together under check your understanding. Simplify each expression and justify each step. So I typed these out because there was more. I couldn't write this much with my handwriting so it'd be legible, so I decided to type it out ahead of time. So here we go. The first problem, A, 5a plus 6 plus a. So I rewrote the equation, and then here it is. And what I've done in the first step is we added the 1 to the a. Okay, and we can do that because the identity property of multiplication says that we can add 1 or multiply 1 times any number and still have a. So we didn't change the value of a, we just put a 1 there so it's obvious when you're looking at it. Okay, you don't have to do this, but it's understood to be 1, but I just wanted to put in there to make sure we can see it when we're doing this. The next step is to swap the 6 and the 1a places. So now we have 1a in the middle and the 6 at the end. That's the commutative property of addition. Allows us to switch them around. And why did we do it? So that we could have the 5a and the 1a close together. So now we can use the distributive property to remove the a from these two terms. And we get 5 plus 1, the quantity, 5 plus 1 times a plus 6. That's the distributive property. I pulled out the a, okay? And then when we're left through addition, we add these 5 and 1, and we get 6a plus 6. So problem B, 2 times the quantity, 3t minus 1 plus 2. So here I rewrote it. Then using the distributive property, I multiplied the 2 times the 3t and got 6t right here. And the 2 times the negative 1, I got a negative 2 and had 2 from the equation left over. Then that's the distributive property. Then through the definition of subtraction, I converted the negative 2 to plus a negative 2. Okay, and now I regrouped. Through associative property of addition, I regrouped. Here's the regrouping right here. I put these brackets right here. I've regrouped those two 2's together. So now I have a negative 2 and a positive 2 grouped together. So I'm adding a negative 2 plus a positive 2 using the associative property of addition. And once I do that, I get 6t plus negative 2 plus a positive 2 is 0. That's the inverse property of addition. Okay, a number plus its negative is equal to 0. It's the inverse property of addition. When you do that, now the 0 obviously goes away, so we're left with 6t, the identity property of addition. 0 plus any number is still 0. The number rather. Okay?